welcome to Shelter in Place 6th grade science. I'm Miss Basor, here with you today to talk about the water cycle. So the water cycle is amazingly simple and yet very complex. And the water cycle is this continual movement of water on Earth. Movement of water from in the air, what we call the atmosphere, movement into what we call the hydrosphere, which is the liquid water on Earth, movement into the lithosphere, yes, there is water inside the solid Earth, and then water into all living things, what we call the biosphere. So the water cycle really connects all these different parts of our planet, from non-living to living things, and it's how water is constantly reused. Believe it or not, we are drinking the same water that the dinosaurs drank, or Julius Caesar, or Cleopatra, or whatever historical figure you want to think of. You're drinking some of the water that they drank and then they peed out. Yeah, kind of cool. So we are going to look today, a closer look at how this process starts, how we go through evaporation, condensation, precipitation, and then collection. And we'll also start to work our way towards something called evapotranspiration, a very fancy big word, which just basically means water that ends up in plants, which we'll see later and even do an experiment about. So let's dig in with the water cycle. Let's head outside because the water cycle is actually happening as we speak. The first step of the water cycle is happening in my backyard, so we're gonna go check it out. Let's go take a look.
Okay, so we have the water cycle happening right here. See this big puddle here from all the rain we've had? It's just sitting out here chilling in the sun. But this is really where the water cycle is getting its start. Water that sits on Earth, whether it's in puddles or it's in lakes or it's in rivers, it's going to sit in the sun. And if you remember, the sun is very warm. I have my thermometer out here. I'll zoom in a little bit so we can see here. So definitely the sun is warm. Let me zoom in even closer so we can get a reading on it here. So we can see it's about a little under 90 degrees Fahrenheit or about 30 degrees Celsius, and this might seem a little bit shocking because it definitely doesn't feel like it's 90 degrees out here. But the sun is definitely shining on the ground and making the ground surface really nice and warm. And if you guys remember from last 2 weeks ago, we talked about that a small layer of air above the ground is going to get heated by conduction, and then convection currents are going to move that air higher up. But we have to remember that water vapor is in the air. So those convection currents that we talked about that are moving heat, they're just not moving heat, they're also moving water molecules. So the water that's sitting here in this puddle is going to make its way up into the atmosphere by a process we call evaporation. So what happens after all those water droplets make their way into the sky? Well, we can see this here with this bottle that I just happen to have sitting outside. And I've had it outside for a couple of days now, and what you'll notice is the water inside has started to condense, or what we call condensation. If I zoom in here, you can see all these little tiny droplets coating the inside of this container, and this is exactly what happens high up in the atmosphere when the water vapor that has evaporated starts changing from a gas back into a liquid. And this is happening here because the water that's sitting inside here was sitting outside all night. It was getting very, very cold, and now that the sun is starting to shine on it, that cold water is condensing or changing back into a liquid. It had been a gas, now it's a liquid. So this is an example of condensation, which is the second step of our water cycle. And then the last part of our water cycle is precipitation, which we can sort of see happening here. So eventually those clouds in the atmosphere are going to get too full with water. They're not going to be able to hold it. And then slowly but surely that water is going to leak back down to Earth. And we call that step of the water cycle precipitation. Now, this is technically not really precipitation. I overfilled my flower pot up here with water, and then what the soil can't hold is dripping down, but this is a great way to represent precipitation, which is the step of the water cycle where the water in the clouds leaks out and back to the ground. The next step of the water cycle is called collection, and if you notice here, I'm still watching this water, and you can see that it's slowly starting to run away from the place where it initially poured down. This is the part in the water cycle that we call collection, because collection is where water basically fills up different places on Earth. So what we're actually seeing right now is what we would call runoff. Runoff is water running off of the land into other places. It could be running into a creek, could be running into a river. In this case here, it's going to run into the crack in the sidewalk, and then that crack in the sidewalk is also attached to the grass here. So this is the same thing we see happen on the surface of the Earth after we have precipitation, whether it's rain, snow, sleet, or hail. The water is going to collect or make its way to a place where it can join together, and then that will eventually start our whole water cycle all over again, because these places where the water collects are where the water is going to evaporate and head back up into the atmosphere. Okay, so now we've gone through pretty much the entire overall water cycle. It starts with step letter A with evaporation, which is powered by the sun. That causes liquid water to turn into gas. Then when the air cools, we get step B, which is condensation, where gas turns back into a liquid, so water vapor in a liquid. And then step C is precipitation. When the cloud gets too heavy to hold the water, it comes back out. And then step D is collection, where water returns to Earth's surface and stays stored there until the whole process is ready to repeat. But let's look at a couple more vocabulary words related to the water cycle. So speaking of water vapor, water vapor is in the sky, it's around us as we sit in our house, it's everywhere, and you can't always see it. And we have a word in weather that helps us better understand water vapor that's in the air. So a good way to think about the air is kind of like a sponge, and it can hold water. And there's a measurement for how much water the air can hold. So for example, the sponge that's in the picture is definitely at over 100%, right? It's definitely full of water and beginning to leak out. So the word that weather forecasters use for how much water is in the air is called humidity. Humidity is a measure of how much water vapor is in the air. So if we have a high humidity number, like 80% humidity or 90% humidity, that means that there's a lot of water vapor in the air. This also explains why, when the humidity is really high, we tend to feel rather sticky and uncomfortable because the air is really full of water vapor. It can't evaporate anymore, and so things like sweat sticks to our body and we feel really uncomfortable. Humidity is also a way that we can predict if it's going to rain soon. As the humidity creeps closer and closer to 100%, that means that the air, just like the sponge there, is going to run out of space to hold the water vapor, and it will eventually turn to liquid water and then begin precipitation. So if humidity is a measure of how much water vapor is in the air, can we always see this water vapor? Well, not always, but we can when it starts collecting on specks of dust and other particles. That brings us to clouds, right? Clouds are how we can actually see that there is water vapor in the air, and that water vapor has started changing from a gas back into a liquid. So how does this happen? Well, high in the troposphere, where it is cold, water vapor condenses into tiny liquid droplets that collect on dust particles to form clouds. When these water droplets combine and they grow larger, then they can fall to the ground. And we have a lot of different names for that, but the main name that we use in the water cycle is precipitation. Precipitation is any form of water that falls from clouds and reaches Earth's surface. Let's start with the precipitation that you're most familiar with, which is rain. Rain is the most common kind of precipitation, and basically we say that a drop of water is rain if it's at least 0.5 millimeters in diameter. And just so you know, as you can see here, real raindrops are actually spherical. I know that we tend to draw them as kind of tear-shaped, but that's because the raindrop gets stretched out as it falls downward because of gravity, but in reality, raindrops are definitely circular or spherical shapes. So rain is pretty simple. We see this all the time. A type of precipitation that's a little bit more complicated and one that we do not see in San Jose is snow. Snow forms when water vapor in a cloud is converted directly into solid ice crystals without ever passing through the liquid phase. I cannot stress how important that is. Snow is so special, and its snowflakes have 6 sides or branches because of the fact that water vapor, which is a gas, changes directly into solid ice. There's no in-between stage. So it's not like we're gonna go gas, liquid, and then solid. This is going directly from a gas into a solid. And this is why snowflakes are so unique. This is also why snowflakes kind of behave differently. Each one is a solid, but they kind of can clump together to form these larger solids. Snow is really unique, and this does require freezing air temperatures. So we're talking temperatures of 0 degrees Celsius. The one that's a weird in between that is kind of complicated is sleet. And sleet starts as raindrops. They're raindrops that are falling from the sky, but then they freeze in the air on their way down to the ground. So they definitely are a liquid before they freeze solid, but because of the fact that they start as a liquid, then they change to a solid, it means that they're not very light and fluffy. And basically, if the ice is smaller than 5 millimeters in diameter, we call that sleet. And again, sleet is not one of those types of precipitation we see here in San Jose. It's kind of an in-between of rain and snow. The last one is the one that we do sometimes get, and that is hail. And hail only happens inside giant cumulonimbus clouds during thunderstorms. And this is because there are really strong updrafts in the cloud, and what they do is they take rain particles and they shove them back up into the cloud. And then this over time creates hailstones. Each time a new layer of ice gets added to the hailstones as the drops of water fall down, they get pushed up, they freeze solid, they fall back down, they get pushed up again. And eventually, the hailstone becomes heavy enough to actually fall to the ground. And you can see there in the background that hailstones are definitely quite heavy. These ones in the picture are pretty small, but they can get to the size of a golf ball sometimes, depending on the force of the winds inside the thunderstorm cloud. So hail is something we do sometimes get in San Jose. It doesn't have to be something that happens in the winter. I've definitely seen hail fall during like February, March. I've even seen a weird hailstorm in July. So whenever you have a thunderstorm that has really strong updrafts that are going to pull air upward, you can get these hailstorms to form. They're pretty cool. So to wrap up, let's play a little which precipitation is it game. I'm gonna put up the image. I'm gonna give you a moment to think about it. You can call out the answer to your own computer screen and I will reveal the answer. So first up, we've got this type of precipitation here. It can be light and it can be fluffy, but don't let that fool you because it can pile up because it's solid ice crystals. This is snow. Our next type of precipitation, falling from the sky with those circular droplets. We definitely have had this week. This is rain. And this type of precipitation starts in a giant cumulonimbus cloud where updrafts are going to push the water droplets upward and make them freeze into little stones. This is hail. Our next one, I know this image isn't the best here, so let me zoom in. So here it says, precipitation begins to fall as rain, but encounters freezing conditions, causing the raindrops to freeze before hitting Earth's surface. So again, you can see it starts as liquid water, turns to solid. This is sleet. And last but not least, these are pretty big ones here. This entire field is full of them. It's formed from strong updrafts pulling rain upwards in a thunderstorm. These are gigantic hail or hailstones. And last one here, oh, so pretty. They're formed because water vapor changes directly to solid ice. It does not pass through the liquid phase. This is snow or a snowflake. Let's look at another multiple choice question here. It says, when water droplets in a cloud combine, become too heavy and fall to the ground as rain, snow, sleet, or hail, we experience. All of these are what we call precipitation. What do we call liquid spherical water? What is liquid spherical water called? Hopefully you said it was rain. Next one, what do we call rain that passes through freezing air? Rain that passes through freezing air. That is sleet. What do we call water vapor that changes directly to a solid? So the gas changes directly to a solid in the cloud. That is snow. And last but not least, it's falling rain that's forced upward to become solid ice. So it falls as liquid rain, it gets pushed up in the cloud and then freezes to solid ice. That is called hail. Nice job. So that's a quick review of the water cycle and different precipitation types. Next week, we're going to get a little more complicated with cold fronts, warm fronts, and stationary fronts. See you then.